Hello and welcome to our proof of cosine A minus B. We're going to take a geometric approach. There's also an algebraic proof shown in the book. We'll start by constructing some triangles. And to start with, I'll create this right triangle, labeling the altitude as x, this angle that is not specified, but I'm going to call it A. Inside of this triangle, I'm going to create another right triangle by measuring 1 unit from the right vertex and dropping a perpendicular. Okay, this should all be allowed. And then I'm going to take the point down here at the bottom and send it right up to that top corner, creating a new angle B. And then that triangle that's left is going to have a vertex of A minus B for an angle. All right, so let's take this information and reorient it. I've got the blue triangle sitting pretty good. I've got this bottom triangle here. It's also pretty good. This one I want to put the right angle for this right triangle in the bottom left, just so I can do some comparisons. And then likewise. Now notice before I flip this one, notice that this triangle, this black one with the green hash mark, is similar to the blue one. And that's going to come up in a bit. The reason I can say that is they have two angles that are the same, leaving this third angle, A, to be defined in the black triangle. They're simply similar, so there's going to be some ratios that we can use for that. And this one, to flip it over and make it look right, look like this. Before I go too much further, we're going to clean that up. And we get these four triangles. And I'm going to start with the green triangle. I'm going to use some triangle trig here, remembering if I have an angle B and I have a hypotenuse, if I wanted to label this side, I would know that the cosine of B equals adjacent over hypotenuse, so therefore I get H cos B. And on the opposite side, I'll get H sine of B. Following up down on the bottom here, I have an angle A with a hypotenuse of 1. That's rather convenient. That lets me say that the vertical side here is going to be adjacent to A, so it's 1 times cosine A. I can just write cosine A. Likewise, 1 times sine A is the side opposite. I can just put sine of A. And now another connection I want to make, remembering back in this triangle, we had the base of the green triangle plus the base of the black triangle here, the congruent triangle. If we added those two, we would get the exact length of the hypotenuse of the blue. So I can take some of the information I've just found here, and I can say that if I had some kind of a perpendicular here, this length here, we had decided was going to be the base here, H cos B. And if I add the base of this triangle, sine of A, I get the total length of this hypotenuse. You might want to go back and check that makes sense to you, but it is accurate. And now we'll do some algebraic comparisons. We're going to I'll start in the bottom left here. If we simply wanted to know the cosine of A minus B, what it equals in this triangle, it equals adjacent over hypotenuse. So cosine A minus B equals x divided by h. And I want to solve this equation for x. I simply multiply both sides by h. The h cancels out on the x side, and I'll get an h on the left side, giving me x equals h cos A minus B. I'm going to go over to this right side here. I'm going to do something fairly quickly here. If you remember, these two triangles, they came out of our original drawing that had the same side shared by them. Okay? So I know that those two sides are equal. They're identically equal. So I know that h sine B must equal the cosine of A. And to get the answer for solving for h, which is going to be useful in the future, I'm just going to divide both sides by sine B. And I get h equals cos A over sine B. So that'll be another equation we're going to use. It's going to be rewritten on the next slide. Final thing I want to talk about is these two similar triangles, as was discussed earlier. I'm going to use the property that the altitude over the hypotenuse of two similar triangles will be proportional. So I'm going to get x over h cos b plus sine a has to equal cos a over 1 in this case. All right, this cleans up pretty nicely. I can divide by 1, that's just this. Multiplying by h cos b just gets rid of it and writes it up here. So I'm being a little bit lazy here. However, the math should flow pretty well. I do have to remember that this cos A needs to be distributed in. So the equations that I have that I'm going to work with, and I'd ask you to just go through and verify, are going to be x equals h cos A minus b, x equals fairly long drawn out sum, and then I have this. What I'm going to do is start by setting x equal to x. So h cos A minus b equals this mess. First thing I want to do is divide by h. If I divide by h over here, I'm going to get things to cancel out. And I also want to flip this around. I want to put the cosine A in front just because we have A and B here. So I'm going to rearrange very slightly and get cosine A minus b equals cosine A cos b plus sine A cos A over h. Multiplying by the reciprocal. This h here is actually cos over sine. Therefore, if I multiply by sine over cos, it's the same as dividing by h. Noticing that I have a cosine top and bottom leaves me with cos A minus b equals cos A cos b plus sine A sine b. Voila.